Okay, so on Friday, we looked at ratios going from one-dimensional to two-dimensional and three-dimensional, right? And you were jumping back and forth. If I gave you a 3D ratio, you're able to find the 1D and the 2D and so on. Okay, so really, what we did on Friday is the bulk of the work, but it didn't really do anything for us. So today I'm going to show you how you can use those ratios. Okay, so the ratios alone got you nothing. But today, you're going to see how it all comes together. Okay, so we're still talking about the one-dimensional versus two-dimensional versus three-dimensional. So here's the type of problems that we're going to be looking at. This one says the scale factor of two solids is 1 to 4. So first of all, scale factor, what dimension is that? Scale factor is a one-dimensional. Scale factor is one-dimensional. It says the surface area of the smaller figure is 52 square meters. Find the surface area of the larger figure. Okay, so right now, I have a one-dimensional measurement of 1 to 4, right? I want to find the surface area of the larger figure. Surface area is in what dimension? That's in the two-dimensional realm, right? So I need a two-dimensional ratio. So if my surface, if my scale factor is 1 to 4, that's one-dimensional. What's my two-dimensional ratio? 1 to 16. Good. This is the ratio I need to use in order to solve for my surface area. Okay, so 1 over 16 is one of my fractions in my proportion. My other fraction is going to come from the actual surface area. So it says this, the surface area of the smaller figure is 52 square meters. Okay, so this is where sometimes you have to use a little logic. Which number is going to be smaller, the top or the bottom? Top. So this is going to have to be 52. I'm solving for the surface area of the larger. So we use that 1D, 2D, 3D to help us set up our proportions. Okay, so now I can cross multiply. So I have x equals 16 times 52, which gives me 832. So the surface area of the larger figure is 832 square meters. So it's all about getting that ratio into the dimension that you need and then using that ratio to set up a proportion. Any questions on this problem? Yes?
How do you know that 1 to 4 is
Scale factor is a one-dimensional measurement. Kind of like if you had a blueprint drawing. You know how they have like 1 inch represents 12 feet or whatever? That is a one-dimensional measurement because it's just measuring one length. Does that answer your question? Sure? I'm not really convinced. If you have a question, make sure you ask me, okay? All right, next one. It says the scale factor of two solids is 4 to 9. So scale factor is in what dimension? One dimensional. So this is a 1D measurement. The surface area of the smaller figure is 192, and the volume is 1,536. Find the surface area and volume of the larger figure. So we actually have two problems here. I need to find surface area and I need to find volume. So let's start. We know we have one-dimensional measurement of 4 to 9. Let's deal with surface area first. Surface area is in 2 dimensions. So what's the two-dimensional ratio going to become? 16 to 81. So let's deal with surface area. Okay, we're going to deal with surface area first. So my surface area ratio is 16 over 81. It says the surface area of the smaller figure is 192 square meters. My 192 needs to go in my numerator because 16 is larger than 81. And now I can cross multiply. So I have 16x equals, I have 15,552. So my surface area is 972 square meters, right? Okay, they also wanted us to find the volume. They wanted us to find the volume. So I need my three-dimensional ratio. So what is 4 cubed? 64. What is 9 cubed? 729. Good. So that is my first fraction for my ratio. All right, and it tells us that the volume of the smaller figure, the volume of the smaller figure is at 1,536. I'm going to solve for the volume of the large. So I have 64x equals 1,119,744. Divide that by 64. So I have 17,496, and that's my volume, right? So that'd be cubic meters. So you can see it. Questions on that? Ready for the next one? Yeah. All right. Says the lateral areas of two similar cylinders are 196 square inches and 324 square inches. Lateral areas, what dimension is that in? That's a two-dimensional measurement. Good. Okay, the volume of the smaller cylinder is 686 cubic inches. Find the volume of the larger cylinder. So right now we have a two-dimensional ratio of, well, 196 to 324. Is that okay? All right, I want to get to where? Volume is three-dimensional. I want to get here, but first I need to go back to my 1D measurement. So I need to take the square root of both of these. What's it going to be? 14 to 18. Right? So now we can simplify this if you want. You could do 14 cubed and 18 cubed, but those are huge numbers, right? You are able to simplify this. Just like a fraction you can simplify, right? We can simplify that ratio. So we factor out a 2 would be 7 to 9, which would make us feel a little bit smaller numbers. Not quite as bad. So 7 cubed gives us 343. And 9 cubed is 729. So my fraction is going to be my 343 over 729. That's my first ratio. So the volume of the smaller cylinder is 686. So that needs to go in my numerator, solving for my denominator. So I cross multiply, I have 343x equals 500,094. When I divide by 343, I have 1,458, I think it was cubic inches for my volume. Is that okay? Yeah. Again, it's all about that ratio that we talked about on Friday. Making sure you're kind of looking at the correct language. All right, one more example. Can I change it? All right, last example. So the volumes of two similar trapezoidal prisms are 6,656 cubic meters and 351 cubic meters. If the surface area of the larger prism is 1,280 square meters, what's the surface area of the smaller prism? All right, so it tells us the volume, so what dimension is that? So we're in three-dimensional here. So that's 6656 to 351. And I want to go back to one-dimensional, right? All right, so here's a couple things that you kind of learned from experience. First of all, I'm not recognizing those as being perfect cubes. But how do I find the cube root on my calculator? You have a button that has like an X with a cube root or a square root symbol. You can use that or take it to the power of 1/3. Okay, so if I take 6,656 to the power of 1/3, it's not a nice number, right? You get 18.8 something. All right, so then I usually stop and think. I try to then simplify that fraction or that ratio. You can simplify that ratio. I just did it in my calculator. So if you simplify that fraction, you would get 512 to 27. Do you know how to do that in your calculator?
What?
Do you know how to simplify your fraction in your calculator? Like that? Okay. If you don't, make sure you ask me. Okay, so now I need to see, I recognize 27. What about 512? Is that a perfect cube? Y'all have calculators, check it out. Is 512 a perfect cube? It is. So typically when you're going to do these problems, you're going to have nice answers when it comes to your ratios. Now your final answer may not be nice and pretty, but your ratios typically, especially if you're going to find the cube root, are pretty usually nice and neat. So the cube root of 512 is 8. Cube root of 27 is 3. All right, so now we want surface area, which is two-dimensional. So I need to square each of those, and I get 64 to 9. So because I'm looking for surface area, I need to use my two-dimensional ratio. So 64 over 9 equals, it says that the surface area of the larger prism is 1,280. This time my larger prism is in the numerator, right? Because it's a larger number. So 1280 is going in my numerator, x is going in my denominator. All right, so when I cross multiply, I have 64x equals 11,520. Divide by 64, I have 180. I don't remember what units we're in. Square meters. Questions on that? Yes.
How do you simplify questions?
Okay, so honestly, if you have one of those ABC buttons, the easiest way to do it is make sure it's not improper. So put your smaller number on top. So if you do 351, and then so type in 351, and then type in the ABC button, and then type in your 6656, it'll do that for you. Or I think there's a way, it'll give you a mixed number. If you type in 6,656 ABC 351, it gives you a mixed number. But then I think if you hit like second and then the button above that, it takes and turns it into an improper fraction. Or if you hit second and then that ABC button, I think it turns it into a mixed or an improper fraction. Do you see that?
Yeah.
I can come look at it too if you like to. If you have a graphing calculator, it's done a different way, but it'll do it too. Yeah. You got it? Okay. Yep. All right, the homework is somewhat self-checking. It's one of those where you get your do the first problem where it says start, and then whatever your answer is, that should be somewhere on your paper, and that's the next problem you do. You know what I'm talking about? Like the ladder one you did before, and one leads you to the next. All right. Let me know if I can help you.